So, hello everybody. As Franco said, we will talk today about getting started with Couchbase. And my goal for today is to get you up to speed like that you can, at the end of the presentation, understand how to install the product, use the product, meaning what is a NoSQL document database, see how you can install easily a client, so an API to connect to the database, and start to build your application. So the first thing that it is important to remind at most of the presentation is what are the key differences between relational database and Couchbase. It's not necessarily different a lot because at the end what we manage is data. All the time what we want is to store the data inside the database, inside a store. So it's just, we have to think differently the way we access, the way we organize the data from an application point of view. So most of the time it will be simpler than working with a relational database. But based on our experience, we have been developing with relational database for many years. Sometimes we may have to ask ourselves many questions. This is why we put in the slide unlearn what you have learned. So let's start with some very basic description of relational database. We have tables that represent data in rows, and each rows have a number of columns. And the important part about that is to be able to do anything, you have a very strong schema. You have created a schema with a different list of tables, each table having columns, each column having a specific type. So it's a very static schema. And you have, in these specific columns, many types you can use, string, numbers, date, time. But there are one specific attribute, so one specific columns will always be on the same type for the full tables. So if you want to create complex data types that you want to integrate inside your relational database, you cannot do that in a single table. You have to separate that in multiple tables. So if you have an order, an invoice on some item, you need to create the two tables, order and item, that will represent the different type. So this is what we call the impedance mismatch, where it makes the complexity of managing the data. Not only it's hard to represent complex data types, but also all rows in a single table have an identical schema. They are all the same. If you want to start to change stuff, you may sometimes have to put some record on some specific part of your database offline. Or it's not offline, as we have to stop the database. But if you want to alter the schema, you have to put some lock on the table, for example. And when we say that all the rows have an identical schema, it could sometimes make the life very difficult. And the sample that I use most of the time is if you create a product catalog and you have a product selling bikes, t-shirts, and shoes, if you talk about the size of these different items, size of a t-shirt, it's a letter, X, XL, medium, so M. The size of the shoe will be, depending on the country, a number, and the size of the bike, depending on the brand of the bike, it could be a size in centimeters or XL and so on. So you see here that for a same concept, name a product, an attribute or a column is named size, we won't be able to really make it easily in the good type inside the schema. So to solve this, Couchbase has chosen to use a document approach. So it's a key value document where the key will be the primary key you access the data, and the document is what you store. So you can store different type of data inside Couchbase, anything you want, strings, numbers, date, time, booleans, binary file, that will be exposed for your API as base64. Keep in mind that they are not stored in base64 on disk. We just store the bytes as you send them to the database. But when you want to create more complex data type with a schema, meaning with the fact that they represent a specific applications application element like the product I was talking about. You can do that using JSON. So we choose to use JSON for the simplicity. And you can really integrate in this very complex element or nested element, nested object inside one single document. Inside Couchbase, JSON are very simple strings that we store. We just recognize that it's a JSON element to make the life easier for the developer, but also we will see later to be able to query the data in the JSON document based on some attributes. What does that mean from the schema point of view, from your application's point of view? In one case, relational database, the database is responsible of the schema. It's responsible of checking that everything is compliant with the schema that you have defined. In the context of Couchbase on a document database, this is the application that uses the schema. So it's not forced by the database, it will be controlled by the developer. That means to be able to change or improve the schema of your application, of your data, you just have to do it inside your application. Either you do that on a lazy way when you access the document and you know that you have to add some attributes that transform specific elements inside the document, you do it, or you can do it by batch. But this will be done document by document when the database is online without impacting the other documents that are not that have no impact on the change you want to apply to the schema of your application. So dealing with a complex data type in a relational database has been always a very complex thing. And what we have done in many languages is we build ORM, the object relational mapping tools. Typically, if you look at this Java class, you have a set of basic attributes, name, email, age, gender, and date of creation. But you want to be able also to list more complex elements like items, preferences, the books that I have written. And if you represent this inside the database, you have multiple tables, sorry. So this is hidden, the complexity of the schema you have behind the scene is hidden by the object relational mapping. But keep in mind that this specific organization has a cost. This specific way of hiding this complexity has a cost in speed and scale of your application. Where if we look at the way you will deal with the data inside Couchbase, you just take the document, you store it as it is, you get it as it is. You don't have any complex operation to do. It's really the developer that will choose how he wants to organize the documents in one single document with sub-element. As you can see here, item views, preferences, and author are a list of attributes or a list of objects, JSON objects that are nested or embedded inside the JSON document. You can, in some case, separate that in multiple documents depending on the use case, depending on the way you deal with the data inside your application. But I want to keep it quite simple as a beginning, where if your application wants to deal with this set of data with basic types plus sub-elements that are complex, it's definitively a lot easier in JSON database because you get the document as you want to use it inside your application. You save it the same way inside your application. You don't have multiple tables to update. You don't have complex query to do. Even if sometimes these multiple updates or multiple insert inside your database or the query is hidden from you because the object relational mapping tool is doing it, you still have to do it, or your application still have to do it. So how does Couchbase work in terms of product, in terms of how do you interact with the database? One important part is, and we will see later, you have to install the server. So the server could be in development mode, installed on one single box, your development platform. And when you have installed it, you will go to your localhost or server name 1891. This will give you access to the console where you can see how to organize your data in different buckets. So it's a different namespace where to source the data, organize the contents the way you want, how many resources do you want to give to your application in terms of memory management. And if you go to production or pre-production, you will obviously use multiple nodes because Couchbase, it's a distributed database. It has been built to be deployed on many servers, and the developer will see only one single database. The same way if you have one node, or if you have two nodes, or if you have 50 nodes, it's transparent for you. So how do you interact with the database? We will see that from an API point of view in a minute. But what is important to understand inside Couchbase is to see how the data are coming back and forth from the database. So the first thing is when your application that is at the top, and whatever technology you use will be exactly the same process. Is the first thing that we do when you want to save something inside the database, we go in the database cache. And the database cache is a specific space that you allocate inside your servers. And I say servers because you will have multiple nodes inside your cluster. And once it's saved in memory, as a developer, you can choose to just immediately get back the answer, the response from the server, or you can choose to wait until it is persisted on disk and replicated on another node in the cluster. Because keep in mind that because we are a distributed database, that all the documents on all the nodes of the cluster, because we have distributed evenly on all the nodes, all the data, to be sure that in case of failure, if you lose one node, we want to be sure you don't lose any data. We use the replication queue to push one or multiple copies of the documents. This is something you choose as a system administrator. As a DBA, you choose how many copies of the document you want to have on other nodes. These copies inside Couchbase, so the replicas, are only used in case of failover. We only have one single active version of the document in the database at a specific moment of time. And this is quite important because this gives you a consistent view on all the data, independently of the fact that we are a distributed database. So when it's saved on disk, if you want to update the document, it will be the same process. We first save it in memory as fast as possible. It will be saved on disk. It will be copied on different nodes. How much time, how long it will take between the write in memory and the write on disk? It will mainly depend on your hardware and the number of writes you do at a specific moment of time, number of operations per second. It will be faster on a SSD system than on a normal hard drive. It will be faster if you have a large number of nodes and you want to be sure that you distribute the load evenly by looking at how much time and how full is the disk queue between the memory and the disk. So this is something that system administrators, this is something that DBAs are used to monitor, and Couchbase gives to the system administrator all this information. You as developer, you just have to keep in mind that you can choose to only wait until it's saved in memory, or you can check if it's saved on disk or replicated onto another node. When you want to read the data, most of the time, depending on the sizing of your cluster, you will get the data directly on the server. So this means that we are a very, very, very fast database. And if you want to know which protocol do we use between the application server and the database, we are using a protocol based on the memcached protocol. This will help us to be not only very fast on a very simple API, but also compliant to any existing memcached application that has been built today. You can switch and replace and use a database or a cache as, using Couchbase instead of using the memcache server. So we see that you can save the data inside your database, you can get the data inside your database, and this inside a cluster of multiple nodes. And the way Couchbase has built is partitioning of the data. So the way we do copy the data and distribute the data on different nodes, it's something that we share between the server side and the client side. So you need specific client API, so specific SDKs to be able to save the data inside Couchbase using the specific protocols that I was talking about. And what we have is we have many SDKs depending on your programming language. So for example, here, if you go to couchbase.com/communities, you have all the supported languages that we have: Java, .NET, PHP, Ruby, Python, C, and Node.js. In addition to that, we also have community-driven SDKs for Go, for Erlang, for Clojure, and so on. And in the case of PHP and Ruby on Node, we just use that as a wrapper. So it's a wrapper at the top of the C library. Like that, you can deal with the same efficiency that you have in any other languages. So Java, .NET, and C are the native SDK, and we have wrapper for other languages. So once you have your code, once you have the SDK installed, you use your favorite editor or IDE to connect to the database and to get the data back in and out of the data. Here I saw some code with, you can see some code with Ruby and Python, where what you put the bucket and the hostname of one or multiple nodes inside your cluster. Same in Python, you will put the name of the bucket and hostname if you don't want to use localhost. And what is interesting here is look at the way we manipulate the JSON document. So the data object, it's a simple JSON object in both languages, and we do cb.add to save the data into the database. And if you want to get it, you take the key that is called my data, and you get it back, and you can do whatever you want with this specific information. And the bucket, as I mentioned before, is just a namespace where you want to store all your data. If you want to compare to a relational database, it will be more or less your schema, or more or less your global database, where you put all your information. It has nothing to do with a table, for example. It's really a place where you put all your data. So in Java, you do the same. You want to connect, you get the specific URI to your cluster, one or multiple nodes, and you use a specific bucket name, in this case default, and when you want to save some data, you will just take a Java object, for example, if you want to put it as a JSON. You use a JSON library to serialize, deserialize, and you do cb.add my data and a JSON to JSON information to store the data. So about the connection string, what is interesting and what is important to understand is, in this specific case, I'm connected to one single node in my cluster. Maybe I have one node, or maybe I have 5 nodes in my cluster. As soon as I do the new connection, the first thing that the system will do, the SDK will do, it will get the map, so you will get the topology of the cluster to know how many nodes do we have right now inside the cluster, to be able to push and to set and read, set and save and read the data from all the nodes. And this is something you do transparently. The reason why we have a list of URI, so a list of host name and port, it's simply because suppose you were trying to connect to a 5-node cluster, and if you put only one address, and this address that you are trying to use is not accessible, you cannot connect your application to your database. And what we want when you use Couchbase, we want your application to always be on. So you want to be able to try on another node to see if you can connect to the cluster, even if you have only 4 nodes instead of 5 nodes up and running. So this is why in the best practice, you will see that usually put more than one address in your connection string. Node.js and PHP will be exactly the same model. So you get the connections, you do the add, you do the get, or you do the set to save. So what we have done also, if you look, it depends if you are a polyglot programmer, meaning if you use multiple technologies. But most of the operation will have exactly the same name, exactly the same list of parameters you can receive. Obviously, we try to adapt also to the way people are used to program in specific languages. But you will see the set, the add, the different operations available for all the languages. What if I go back one slide, you see that when I do an add, I use my data as a key and data as value. The key is something that the developer is responsible of providing to the database. So you put a key on a value, the value could be anything you want. But the important part to understand inside Couchbase is as soon as you have the key, you have a very, very fast access to the database. So you can build the key in different ways. You just have to remember that it could be anything, any string up to 250 characters. They are just unique in one single bucket. So if you are reusing or trying to reuse an existing key, depending on the operation you do, if you do a save, if you do an update, or if you do a delete, it will replace, save, or delete the key that you are trying to modify or you are trying to use as parameter. And remember, it's your responsibility as a developer to set and give a specific meaning to the key. About the value, it could be anything, as we said before. Most of the time when people are using Couchbase as an application database, they will use JSON document, but you may want to use other type of structure. But let's say JSON is the most common use case for Couchbase as a document database. But it's quite interesting to know that you can store anything up to 20 megabytes. So meaning sometimes people are storing result of a calculation or a portion of HTML pages or even images, small images inside Couchbase to have a very fast and very reliable database on cache, depending on their application. So the key is your responsibility. You can store anything to 20 megabytes. So this will allow you to build other operations that you can use inside your application. We have seen some of them. We have seen the get and we have seen the add. So basically, you have a very simple list of operations. Get, set, add, replace, and cast, for example. The get, as the name said, it will use this key, immediately calculate on which node of the cluster I have to go to have the values to get the value, and do a call to the cluster and get the value. And you have also in the SDKs what we call the multi-get that allow you to provide a list of keys and do the same. The application will call the cluster and get back all the keys that you have, all the values associated to these keys, and return null if you don't have any value associated to the specific key. Then you have the operation you use to modify the value. Set, add, replace, so modify or save the value. Set will take a key on a value. As you can guess, it will save the data in the database. And if the data, if this key does not exist already, it will create the key and save the data. If the key already exists, it will override the existing value. Add will only be successful if the document associated to this key does not already exist. If this key already exists when you try to use the add operation, it will raise an exception. The replace will do the opposite. If you try to do a replace on a key that does not exist, it will raise an exception. If the key exists, it will replace the document. So what I said that is something quite interesting, especially with the set operation. If the document exists, it will immediately override it. But if you are in a very concurrent environment, when you have many people that could modify documents, that could add information inside the database, you may have some concurrency problems because one guy will try to save the data, then you have two other persons that will try to save or update the data. And you don't want all the time, and I will say most of the time, you don't want to have the last guys or the last thread to do the operation to win. So what we have a specific operation that allows the developer to control if the document or the value has been modified by somebody else before he was trying to save it. It's what we call CAS, compare and swap. It will only be successful if it has not been changed by somebody before you. And the way you do it, when you get the document to update the document, you get a cache number. This is an internal number that we use inside the database that you will reuse when you save the data using a cache operation. So the last one on the list of operations on this slide. And this is typically something that we do very often also in our web application using relational database. We do optimistic locking. We don't want to put any lock, any real lock on the server side because it will have an impact on the performance of your application. What you do, it's an optimistic locking. With Couchbase, the developer will choose, depending on the use case, depending on the path of your application, the business logic of your application, you will choose if you want to save or not the data if it has been modified by somebody. And as a Java developer, for example, it's something that happens automatically with Hibernate by default if you want to do optimistic locking. Here, as a developer, you really choose if you want to replace the data or not. And another important concept that we are using a lot, it's a concept of counter. And this is something that allows you to create a key, and associated to this key, you will be able to increment and decrement an integer inside your database to be able, for example, to generate keys, unique keys inside your system. This is really equivalent to what you have in a relational database when you use a sequence. You have a counter that is incremented, and you use the value of this counter to, for example, use a primary key of your of a specific role. So it's exactly the same here. You will use increment and decrement of a specific key to use as a reference to another one. And I will try to show you that in a minute. So what we have seen in a little bit earlier about the code is the fact that when you want to store documents inside the database, it's your application that is responsible to serialize the object from your language object to a JSON document. In this case, what we have is typically the document, the object that you have in your application will be serialized to JSON document string and saved inside your application. And this is interesting because we don't want to do that directly in our SDK, because today, most of the programming language provide a very rich set of libraries to do the serialization and deserialization of objects to Java. So PHP, Ruby, JavaScript have all tools to do that from object to JSON. In Java, in .NET, you have many libraries that allow you also to control the way you want to the system to behave if you have nested elements, so nested objects. Keep in mind that we don't do anything with the data. We just take them, store them in the database. If we ask them with a get, we give them out the database the same way you have stored them. So if you use a powerful serialization API for JavaScript, or JSON object, sorry, you will be able to use it from end to end inside your application. So before going to more information about how you use keys and values inside Couchbase, maybe I could take some questions about the product itself.
Thank you, Tag. So yes, let's cover a couple of questions before we continue the presentation. We have a question here about using Couchbase as a cache. So can you use Couchbase as a cache as well?
So the answer is yes. And it's not something that we'll cover today because we try to explain how to do schema and application development. But we have many use cases where Couchbase is only used as a cache with two options: to only use memory or to still use disk to be able to store more data than cache. More data than cache. I'm trying again. More data than RAM that you have on your cluster. So yes, it's used a lot, and especially we have been very successful as a in-place replacement of memcache in many environments because we provide support on distributions and enterprise management of your cache.
Okay, we have another question from Samarjit. Is what happens if the size of a node is not sufficient enough to store all data?
So the thing is, you have two things. Is if the node doesn't have enough memory to store the data, meaning because we will keep some data in memory for a while, like any cache. If it's only the data, it will save them on disk. If you don't have enough room on your disk, you will have an exception. The same way that if you try to store more information in your database, that we will not be able to save the data. So we will raise an exception that you will have to capture inside your application. Inside Couchbase, you have many tools to monitor the state of your system. How much memory do I consume? If you want to put a threshold to say I don't want to go over 70% of my of the RAM that I have allocated to Couchbase, or if I go over, I want to be alerted. Same with disk, same with many other information. So what's happened is if you start to be short on resources, it could be memory, or it could be disk, you can obviously add more hardware, so RAM uh, or disk space on your existing cluster, and distribute what we call rebalance the data on the new nodes you have added. So as part of the work of the system administrator of the DVA, it's typically to look how good are my resources. Do I need to add more memory? Do I need to add more disk to my database just to be sure I don't have any exception?
Okay, perfect. Thank you, Tag. Let's continue now with the presentation, but we will cover more questions at the end, so please keep asking questions using the chat box.
Okay. So now that I have introduced quickly that the key differences between relational database, now that I've explained how do you install or that we have multiple SDKs on the basic operation that you use to save data. Let's see that because we are also, in addition to being a document database when you can query documents, you can also do very smart and efficient patterns with simple keys. And this is what I want to explain here, and it's part also of our developer books and sample apps. So usually what you have, you will have one single key for the document. So it will be an ID that is up to 250 characters. And you as a developer will choose to organize that the way you want. For example, if you create users, you may want to use either the email of the user or the Twitter ID of the user, or for a product, you want to use an ISBN as a value. And as you can see on this slide, I use u -- John, or u or p -- with a number. It's just a nice way of organizing your keys by providing a prefix to the key, just to, like that, you can quickly know if it's a user, if it's a product, and so on. This is not something that is mandatory. It's just something that you want, the way you want to organize your key inside your application. Personally, it's what I use in most of my applications. I use a prefix that is a type of the data that I'm storing. Because in a bucket, you can store anything you want. It could be product with user, but you can also add game information if you have a social gaming in the same bucket. I don't say that it makes sense, but from a technical point of view, you can do it. So having a prefix to the key, it's quite interesting to kind of see which type of data I have stored. So if you have this kind of keys, it's quite easy to do a lookup, to do a get. You say, I'm looking for John, and I know that John's email is john@demo.com. I do a get of the key u-john@demo.com, and it's done. And this is really what we do most of the time. But if for whatever reason your application is using some keys that you don't really control, it could be very hard to reproduce the key. And I will say an example. If your application is capturing Twitter feeds or Facebook feeds, they are big numbers that have no significance, no meanings. So you want to be able, if you want to query, for example, give me the tweets for this specific user, you need to be able to query based on an index, based on what we call inside Couchbase a view. And I will see that in a minute. But you can do something also with keys that will be related to the counter. So one way will be, how do you, if you have, for example, product or user, and you don't want to use an email, what you can do, you use a counter. So you will create at the data, you will increment the counter key. When you have the result of this increment, you use this value in the key. So add with a prefix key plus the value of the counter, and you get it. And if you want, for example, to get all the keys that are related to this specific counter, you get the value of the counter with a get, first line of the iterates through collection section, and you do a multi-get. It will give you back very quickly all the keys and document associated to these keys in the different nodes of the cluster. So it's really equivalent to the identity and sequence. And in this case, you will just have to initialize the counter, and every time you want to add a new value inside the database, you will use the increment command. So it's really something that you will see a lot when you have master detail kind of operation. For example, if you want to create a blog post, and the blog post has many comments, the way you will do it is to save that with an increment for the number of comments you have inside the database or inside the blog post. Like that, you have a unique ID for all the comments, and based on the prefix that will be the title of the blog or the name of the blog, you will quickly get access to the command. So when you have keys that are UUID, for example, and I was talking about other Twitter ID, for example, so the Twitter message ID, you cannot really use that directly because it doesn't make you don't have any meaning from your application. So when you want to add, for example, a specific data with the ID 550E and so on, when you want to save that inside the data, and you know that it's related to the user John, and John has an email on a Twitter ID, what you can do, you can create another key that will be related to this one that contain an email, and the value is the ID of the initial document. So this is a second line of the slide. And if you want to be able not only to get the user by this email, but also by his Twitter ID, you will store the same way the Twitter ID as a key, and the user ID itself, the real user ID, as a value. And if, in some case, you may have multiple users associated to the same Twitter ID, you, instead of using a simple string as a value, you can store a list of strings that will represent the list of the keys that are related to this user. And when you want to get the user, for example, by his email, you do get from Couchbase with the email john@demo. It will give you the key of the user, and you redo a get. And when you do that, it's true that you are accessing the database twice. But keep in mind that most of the time, you will have the document in memory. And if it's not in memory already, it will put it quickly in memory, and it will be managed by the cache of the database. So it's a very, very, very fast and efficient way of accessing the data, even if you have to hit the database multiple times. This is a quite different approach that we see in relational database, when we try from our application to reduce the number of calls to the database. But Couchbase has been built to handle thousands of operations per second. So don't worry, you can access the database as much as you want. So this specific approach on the lookup pattern is you are building yourself using keys and value indexes to access your data. Indexes that are simple other keys and value inside the database. So the lookup is you create the primary key, you do a lookup document. And really, yes, as I just said, you use 2 gets, but it's okay, very fast. So if we look, a complete pattern will be to use a counter plus lookup keys to create an application. So this is a typical use case that you will see when you want to build an application where the keys are just types, for example, user, product, and so on, and you don't want to use in the main key a specific string, but in simple integer as a value, and want to do more advanced queries on different attributes of your document. So, as I said, the pros of using lookups with or without counter ID will be it's binary operation. Everything will be based on keys in memory. Documents will be cached automatically. So it's very, very fast. And even, it will be very, very fast even if you have a large cluster. Because, as I said, the way we work with Couchbase, the client SDK, based on the key, will immediately know on which node of the cluster he will have to go to get the value. So it creates several ways to find the single document. And because we have a single copy of all the keys in memory, the replicas being here only for failover, you have a consistent access to all the data inside your database. But it's true that you may have some constraints. And one of them is you adding more keys. Because, for example, if we look at the user example, you have the keys of the user plus the keys for the email plus the key for the Twitter ID. For each document, you will have 3 keys that will be managed in memory. Because we don't keep all the documents in memory, but we keep inside Couchbase all the keys in memory. And this for performance, consistency, and latency reason, low latency reason. I won't go into the detail of why we do that more than explaining these 3 big points, but this is a key point of the reason why we can have sub-millisecond latency on large cluster. So if you don't want to create many keys, or if you want to do more advanced queries, like give me all the product that have a price that is bigger than 100 euros, you cannot use keys for that. You need to be able to have a more advanced query engine, or a more advanced way of accessing the data that you have inside your database. This is why we have built views. So let me explain to you what are views and how they are used. So views are used to create an index. It's to create an index that will be stored on disk, and you will be able to use this index to query the data. So the way we have implemented the views, it's using MapReduce approach. And the MapReduce is just a pattern that you use in programming to be able to deal with a large volume of data, integrate also complex document and or complex data structure, and move from a complex data structure to a very simple map with a key and a value. And in this case, inside Couchbase, the map function will be the most important element, where every time you will save a document, so create the document, update the document, or modify the document, or delete the document, the map function will be executed. And the map function will receive 2 parameters. One of them is a document, so it's a value that you associate to the key. The other parameter is a meta. The meta, it represents the metadata of your key and value. That contains the ID, some information about the type, some information about the time to live, if you want to use an expiration for your document, an expiration for your cached value. And you can put any value, any code you want in this specific map function. And as you can guess, we use JavaScript to write the map function. As you can guess, you can put anything you want that will help you to generate an index that represents the values that you want to query on. In this case, I just emit, meaning I just add the doc username to my index, and the value that this second parameter is just the email. This, if we look at what the emit value will do, it will create a key inside the index that will be stored on disk in a B tree that will look this way. So in one part of the index, I have the key that is the email, and the value associated to this specific key is the number of points for the specific user in this case. But also, something that you don't see here, the document ID, the stuff that you use to do set key value, is also stored in the index. Because the goal of creating indexes is to give a very, very fast access to the ID of the document to be able then to query the database using get operation transparently or not to retrieve the document and to get the document out of the database inside your application. So once you have this specific index, you can query it in many ways. And one interesting way of querying the data is to do group by. But to do group by, you have to create it groups, and groups will be built on component keys that are JSON arrays that you will store on disk. A very clear example, or very simple example of that, will be suppose you want to be able to count the number of messages you receive on a specific day or a specific hour or a specific month. So you will take the date, and you want to transform this date into an array, a component keys that will be made of year, month, day, hour, minute, seconds. This is typically why, in this specific example, we will take the timestamp of the document, that will be one of the attributes you have inside your documents, and we use the JavaScript function date2array. That is one of the functions we added to the V8 engine that we use. So the V8 engine being the JavaScript engine we use on the server side, that will create something like that, an array of numbers for the date and the value, allowing you to query that in multiple groups. So to count, for example, the number of a message you received in 2012. And it will be very efficiently stored on disk using a B tree to allow you to do a very, very fast and efficient query when you are looking for the data. So far, what we have done, it's only indexing the document. I've talked about query, but I have not showed you anything yet about the query process. So every time you store the document inside the database, if you have a view, the map function will be executed. It will store the result of the emit on disk in a B tree that will be obviously the same way that we distribute the document. The index will be distributed on the different nodes of the cluster. And now that you have the index, you can start to query the index to, for example, give me all users where the name of the email starts with this specific value and ends with this specific value. So do a range query from B to Z, for example. And in this case, when you do a query, and it's quite important to understand from an architectural point of view, we don't read any JSON document. We don't access really your database. What we access, it's only the index to be very, very efficient. And based on the result of that, you have the ID of the document, and you can query the document. So the query, start key, end key, and other parameters are only used against the index that has been created before. So if you want to have more options, so you will have start key and end key, or you can use an exact match. When you want to give me the different documents that contain this specific value for the index, and you can have multiple mats or multiple mats if you want. A list of keys that will return you all the documents that have the specific keys, or all the IDs. So how do you choose between key values and key value pattern that we discussed just before and views? Is we have to remember that keys patterns are using binary operations, so the get and the set directly connected, so they are consistent. And this is a big difference, is because the index has to be updated on disk. It may take a little bit of time to update the index. And when we say little bit of time, it depends a lot of the number of write operations you have on your system, but usually it's few milliseconds or few seconds maximum. By default, we will update the index every 5,000 operations or every 5 seconds, but you can control that also inside your application or as parameter. So key value pattern will be faster, even if the dataset is big, but as the document is created on mutated, the index is updated. So because you may have a little time between the moment you save the data in the database and the index is updated, you may have an eventually consistent system that you have to check inside your application. So if you need real-time interactions, and you will probably use key value pattern instead of views. And if you want to do more analytics on your data, and you accept to have some time an inconsistent view of your data for a few milliseconds, you will use views. Obviously, when I say that, everything could be tuned, and we have specific pattern to solve this eventually consistent view of the data that we can explain in a later webinar. So just before taking the question, what I want to do a very quick demonstration of how you can get up to speed with your system with Couchbase. So I have already installed Couchbase on my laptop using one single node, but I want to show you that you can also install Couchbase using a command line tool. And for this, I'm using the management tool that will do the installation for me. And I will show you the script just when it's running. And this specific tool will just run the different commands that we have available for the system administrator or the developer to do command line interface to install the cluster. And what I do in this specific tool is I deploy Couchbase on a 3-node cluster in different VMs. So if I go now to my VMs, I have a 3-node cluster. If you look, I have different nodes. I have a bucket in which I can start to put data. And I can modify the JSON document. It was quite easy to install the server. If you do that on your single node, you will probably use the wizard that we have in Couchbase to configure the database. Now that I have installed my server, I want to connect and use a programming language to develop my first application. So the best way to do that is to go to Couchbase communities, choose your programming language, and I will take Java. And each of these SDK have the same kind of layout where you have the getting started, that is a very basic steps to check it's working properly. You have the tutorial, that is a complete application that you build using Couchbase in Java in this case, in all the other languages, and the API. Just let me do one thing on my cluster, is to install the sample application, sample data. So if I go to the Java SDK and I click Getting Started, it will give me all the steps to write my first application. So what I do here, for example, I have installed the server. I want to use Maven, so dependency and project management tool in Java. And I go to my Java IDE, and I will add Couchbase to my project. I have an empty project that I've just built. So I am using the latest and greatest Java SDK. And now what I want I want to use to write my first application. So new Java class, and if I go here, I will just say hello world. And I will just copy and paste the source code and show you in detail what this stuff is doing. So my application connect to my local instance, get a connection, and store a document, retrieve this document. But what I want to use is I want to use my cluster. And I can take any of the machines, VM1, VM2, or VM3. It's not important to connect to the cluster. And I will, instead of using a simple string, I will use a JSON document. Just to show you that you can store as kind of data. And for this specific demonstration, I will just use a string that if you are working for your application, you will use a JSON library to serialize and I will put here the data. So by doing that, I'm setting inside the database a key, the data, and I'm retrieving them and printing them inside my cluster. So let's execute this program. So we see we retrieve the data. If I go inside my database, and as I say, I can take any cluster, any node in the cluster, document, I have my first document that I have created. If I go to another VM, another node of my cluster, I have exactly the same view, and I can view exactly the same data. I don't know on which node this specific document that I have just created is saved. So depending on your programming language, you can do exactly the same. If you are, for example, a .NET developer, you will have the getting started and how to install on more or less the same code to use the information. So I am open for questions. Franco?
Yes, thank you, Tag, again for the presentation. So we are running out of time, and I would still like to cover a couple of questions, but for those questions that we are not addressing during this session, we will follow up offline in the next few days. So we have all the questions that you have asked during the presentation. So let's start from a quick question here is a bucket the equivalent to a database on a relational model?
Can you repeat?
Yes, the question is a bucket the equivalent to a database in Couchbase?
Yes, it's more or less equivalent to a database, because if you go, for example, in my bucket here, in my bucket, I can create product 1, and another stuff that will be a user 1. So you organize the content the way you want. So yes, it's more or less a database.
Great. And another question is, so what if my data is more than 20 megabytes?
So if your data is more than 20 megabytes and you cannot split it, don't try to use Couchbase for this specific use case. If your JSON document, if it's a JSON document, is 20 megabytes, and I will be pleased to see that, a very large JSON document, you can probably split that into multiple elements. For example, if you want to do a file system management, and this is why it's bigger than 20 megabytes, it's probably better, it's what we see sometimes, to use another storage for the large data, for the file, and use only Couchbase to store metadata inside, to store only metadata inside Couchbase. So I will, when I will answer the question offline, I will probably send you the question about which type of data you are manipulating.
Okay, thank you. Last question before we close this presentation, but again, we will follow up offline to all the questions that were asked. So can I also query keys using wildcards?
So you don't. So what we have inside the views, we don't have wildcards, but we have the start on end keys. Start on end key. So the only thing you can do will be the equivalent of start with or like %, but you cannot do in the current version of the product any wildcard in any location. We are working on a new query language to be able to handle that. That is available as a preview today. But in the current version of the product, only starts with, using start key and end key.
Perfect. Thank you again, Tag. We need to wrap up this session. Again, I would like to remind everyone to go on couchbase.com/download and download the Couchbase and try the software to evaluate all the functionalities and everything that Tag showed during this presentation. Again, thank you everyone for attending, and I hope to see you again at future webinars. Thank you.